Hey guys, welcome to this topics video where I take a basic Pythagorean theorem question and spice it up, where we can use trigonometry to actually find out how high up this ladder has to be. So what I thought about for this question was taking a picture of a tree that I just found online and a picture of a ladder. So try to make it look kind of real, I guess, when you show this to your students, and just having a little clip art or actual pictures help out a lot. So what we're going to do is put a picture of a tree and a picture of a ladder. We're going to make it so that we can use our grid to create a 13-foot ladder, and we'll just use grid lines to be a foot. And then we'll have to answer some questions. And what we'll do is, for this type of question, just using my kind of creativity, I guess, is to actually take our 13-foot ladder and turn it by using an angle slider. So that question, if we were to pose it to our kids correctly, might be, given a 13-foot ladder, what angle would we have to lean our ladder so that it leans against a tree 5 feet away from the base? And then we could also ask the question, okay, now how high up is it, if we can get that to happen? So what I did was I already got a picture of a ladder, a picture of a tree that I got online. Okay, so now what I want to do is put those in my GeoGebra. Okay, so now I'm going to minimize my window so that I can see my pictures. I'm just going to drag my pictures into my GeoGebra window, and we're done with the pictures now. So here's my ladder, which I'm not really seeing. Oh, there's my tree too. Okay, so now what we need to do, if you move these points around, we can change our size and our scale and all that stuff. So to guarantee a 13-foot ladder, let's put on the grid, and notice, we have pretty big grids here, and as we zoom, even though we can't see our axes, GeoGebra is rescaling, which is making our grid lines change, whatever. So I want to make grid lines so that we can measure 13 of these. So right now I think these are a little too big. So here's one way that we can make our grid lines have more of them. I'm going to actually show my grid lines right now. So as we're zooming, you can see it change scale. I'm going to zoom in so that my scale goes by 1. And then I'm going to right click on the graphics somewhere and go to my graphics options. And on my X and Y axes, I'm going to click on each tab, and I'm going to do this distance, and then we can actually set it so no matter what we zoom by, our scale is going to go by 1. And I'm going to do that for my Y axis also. So that now when I zoom, notice it's not going to rescale, and we can get a whole bunch of grid lines now. Okay, so that looks good. So for our right triangle problem, to set this up for our students, we need a horizontal ground line, which let's just use the x-axis for that. Okay, so let's go ahead and I'm going to put my axes over here and grab my ladder, get it up here. So our ladder needs to be 13 units long. So the way that I clip my picture is, hopefully, as we change this, the bottom is exact on the ladder and the top is close enough. So this to me looks like 13 feet, right? And we can even go get as exact as you want to get. So here's my ladder. It is now 13 units tall, and we'll call each unit a foot. So now I can take this picture, as long as I don't move these around. I can take this picture. It's going to be 13 units long. Okay, so hopefully we don't rescale that. So our tree now, we just need a big tree, right? So maybe this can be our tree here. Alright, so the other side of this is we need a perpendicular line, which is going straight up the tree here. And it might help if we use our line tool, and maybe I'll make my line stand out. And I'm going to put this exactly on a point. So that'll help with my, 5 units away from the tree. So there is basically my vertical line, and we're going to say that this ladder can lean on that. So now we have our 13-foot ladder. The question really is 5 feet from the base of the tree. So if we're at 23 here, we'd be on the 18 mark here. That would be 5 units or 5 feet. So we want to figure out this ladder that is on that foot, and we have to lean it. And the question's really saying, if we were to lean this ladder, how tall is it up the tree here? So to make the question a little more mathematically intense, so to speak, let's actually rotate this picture about one of these points. Maybe this point here will be our rotation point. And let's take a slider so that we can control that angle and see what we get. So I'm going to create a slider, stick it anywhere we want, maybe right here. It's going to be an angle going from 0 to 360. We can do a full revolution, and let's make our increments jump up by 1. Even though our trig, we may not get a whole degree, but that's okay. Let's click apply. So now we have this slider that's in degrees. So let's go ahead and rotate this ladder about, say, this point or this point. Doesn't really matter. So I'm going to go to my transformation toolbox. I'm going to grab my rotate around point tool. So I'm going to click on my picture. That's the object I'm going to rotate. I'm going to rotate around this left point. It asks us what angle. So I'm just going to get rid of that angle, and we're going to make it alpha, whatever that slider is equal to. And we want it to rotate towards the tree, so that's a clockwise direction. So I'm going to click OK. So now our ladder, my slider, because I was messing around, my slider is at 76 degrees, so we just rotated this ladder 76 degrees. So now you can see, based off of our angle, that's how we're going to get the lean of our ladder. So now one thing about this, this new rotated ladder is our image that depends on our pre-image. So if I were to try to move my ladder around, because I only really want one, I want to actually hide this. But we can't, because I can't really move this ladder around because it depends on where the pre-image is, right? I can move my pre-image, which will move my rotation, but I can't move my rotation image because it depends on this. So one thing that we can do is we can change this maybe a little more opaque. So if you right-click the original pre-image ladder and go to color, you can change its opacity, and maybe we can make it a little more invisible. But then students will need to know, and we need to know, that the pre-image is what's going to move our point. So we'll make that point our 5 units away. So basically the question is, if we put our ladder 5 feet away from the base, so now that point is now 5 feet away, you know, how tall up the tree does the ladder go, basically, right? And based off our picture, we may need to put this other corner on there. I'm not quite sure. That to me makes sense if that's 13 on this one leg here. So how tall up the tree did we have to go? And you can kind of look and see, you know, we're around 12 something. So that's kind of cool that we could do that. The slider sets it at around 20-ish, but this is where trig can come into play. Again, depending on where you're at and what conversation you want to have with your kids, you might say that in this triangle, we have this right triangle made. Oops, it didn't draw on that. Maybe we'll draw an abstract right triangle. Sorry, I'm using my mouse here. So we know that this ladder is 13 feet long, and it's 5 feet from the base. So we can actually figure out what this angle is, right? What this theta value would be. Where we could take, we have the adjacent side and we have the hypotenuse. So we're going to take the cosine. I really wish I had a better mouse. Cosine of our angle is equal to the adjacent over the hypotenuse. Okay, so if you do this work here, grab a calculator, we can take the inverse cosine. I'm just trying to see how I can do this. View scientific. Great. I thought I knew how to use this for inverse trig stuff. Okay, so to save some time, I just grabbed a calculator that was next to me, and it turns out if you do the trigonometry correctly, we should get an angle of 67.4 degrees that we have to rotate this angle. Actually, that's what this angle theta would be. Now notice our angle, the way that we made this. We went basically from vertical to rotating this angle here. So what we just found out mathematically is that this angle from the x-axis to the ladder has to be 67.3. So our rotation angle is really going, this angle here is what we need to rotate, which is the complement to 67 point, I guess it's 4.38. So we'll say 67.4 So its complement is going to be 22.6 degrees. So we were pretty close, and again, just sloppy-wise, we got to 20. But we can go to 22.6, and we can talk about that would actually make our triangle lean against the tree. And then your basic, you can take trig or Pythagorean theorem to actually answer the question. And I believe that has to be 12, right? So 12 feet high, which if you think about it, kind of looks like what we got right here, right? If you think about that height, there's our 12 feet. So anyways, just kind of a cool way to take a problem that seems boring, seems basic, but change it up to do whatever you want it to do, which adding an angle in the Pythagorean theorem conversation is really a good birthplace of where trigonometry even comes into place. How do we connect side lengths to angles? And this is kind of a cool example to show how we can do that. So anyways, I hope that made sense, guys, and good luck with all that.